difference between them. So using the uncertainty approach. So variance estimated from samples. So 3 cars were tested for mileage with the following results. Compare car A and B, A and C, B and C. For car A, the average was 18 kilometer per liter. So I have not put the units here. Standard deviation was 1.2 kilometer per liter. The number of samples was 10. So from 10 samples, we got average as 18 with standard deviation 1.2 kilometer per liter. For car B, average was 19 with standard deviation 1.8 and number of samples 12. For car C, average was 16, standard deviation is 1.4, number of samples 8. So compare car A and B. So based on average, car B has a higher mileage. Is it really significant? How do we decide? So once again, we have to compute the coverage intervals for the mileage. So standard uncertainty is S by root n. So U is here. Then the T factor based on this degrees of freedom as given here 10, 12, 8. For 8 degrees of freedom, the T factor will be higher. Then the expanded uncertainty is standard uncertainty into coverage factor. So all that we determined. Then x bar minus u, this is the lower coverage interval. X bar plus u, this is the upper coverage interval. So now for A, the lower coverage is 17.14, upper coverage interval is 18.85. For car B, lower coverage interval is 17.85. So that means there is a 95% chance that the true value of B, the mileage of B, will be between these two limits. And the true value of A is likely to be between these two limits. But now this goes up to 17.85, which is below this 18.85. So it may be that the true values are actually 19 for A and 18.5 for B. That is also a possibility. Then we cannot say that B is really better than A. Okay, since there is an overlap between the two coverage intervals. Similarly, car B and C, to compare, car C has coverage interval 14.83 to 17.17. This is definitely below the coverage interval of car B, 17.85 to 20.14. So between B and C, you can say that C is definitely worse. Mileage of C is poor compared to that of B. And car A and B, 17.14, 17.17. Very close. You can't really say whether C is worse than A or A is better than C. It's just on the border. So plotting normal distributions based on the average and 95% coverage intervals. So we have assumed that the means are or the distributions are of distribution of x bar is normal. So that is our assumption. What is the basis of that assumption? The central limit theorem. So central limit theorem says there are a number of sources of uncertainty, all of which are independent. Then the resultant uncertainty will be, resultant function also is likely to be normally distributed. Okay, so between B and C, there is clear difference. Between A and B, there is clear overlap. So we can say that there's not much difference between A and B. But between A and C, it is on the borderline. So maybe if you consider other sources of uncertainty, they may overlap. So we can't say that A is definitely better than C. Okay? So this is how you should consider the uncertainty in when you do any test. Okay, when you test a new. So especially in research, this is very important. So you have to consider this uncertainty. So for example, nowadays, of course, everybody is discussing efficacies of vaccines. So you can try to use this approach for comparing different vaccines. If you search, I think you can get. So for different trials, for different vaccine trials, you get different, the number of people who got infected after taking the vaccine. That you can compare. So average is given, plus you have to determine the uncertainty. So for that, you have to use, so we cannot use the uncertainty what you have learned, we have to use based on binomial distribution. Okay, this is so the P, the real efficacy is assumed to be P, and P bar plus or minus T into root of P bar into 1 minus P bar by N. That will be the coverage intervals for the efficacy. So you can calculate and try to plot the efficacies or compare the efficacies of different vaccines. But of course, there is a danger in that also. We learn in our experimental design portion, next chapter. So what is the difficulty? For example, one vaccine is tested in one country, another vaccine is tested in another country. Can we compare the two results? The difficulty is that the behavior of the people will be different. In some countries, people are very disciplined. So if government says always wear mask, people do wear a mask. In some countries, people are very disobedient. If government says you wear a mask, then they'll say they'll never wear a mask. So we have to, the results are comparable only if you do on the same population. Okay, if you do the tests in different countries, it becomes difficult to compare. Okay, anyway, try to analyze this and post in the forum. So some original thinking I would appreciate rather than just taking screenshots and posting this. Do some thinking. I want to see your thinking abilities improve. Don't just accept whatever is dished out to you. So you have learned some theory now, measurement uncertainty theory. So apply this somewhere and show. Okay, try to determine the uncertainties. And others can discuss. So even if somebody posts, you don't simply post the same thing with different data. Try to analyze this, what is wrong, what could be, can there be an improvement? Like that, try to discuss, not just, so one person posts a screenshot of something and everybody else posts a screenshot. I'll give negative mark if you do that, I think. Okay. Sorry. Okay, so that, okay, so once again, what are the limitations? So again, we have considered only type A uncertainty has been considered in this analysis. But you have learned now how to consider all sorts of uncertainty. So please try to apply this in practice.